Alors, la question de nous, have you flown a 787? No. So 787 has what's called height to take off, and that basically uses the LSP for macro patterns. But that's it. Situations, yeah, but still the decision-making process is too complex because in Autoland, they have certain securities with ATCs, but how often do you not see a takeoff avoided because an airplane suddenly infringes? For those kind of things, the automation is considered. So I would think that besides in low visibility, I think taxi is probably the most stable position. Yeah. Well, and it's not amazing. They're versatile, but they're able to judge it. It doesn't necessarily mean they're better. Yeah, my answer will be the future in aviation training is regarding prevention. They should be aware and mindful of what the airline is supposed to do, and therefore should accommodate to that situation if you're going to find significant avoidance.
Welcome back, ladies and gentlemen. We move on to the next panel discussion. The topic, less human involvement, bringing more safety, question mark. The panel will be moderated by Mr. Georges Rebander from EASA, head of the Air Crew Department at EASA. Georges, the floor is yours. Thank you.
Thank you, Dominique. Ladies, gentlemen, internauts which are looking at us, good afternoon and welcome on board of this panel 3, which is raising the question, less human involvement, bringing more safety, question mark. To answer this important question, I have a pleasure to get in my panel, first of all, Hugues, which I wish to introduce himself.
Just now? Yes. So I'm Hugues Meunier. I'm Director for Standardization and Regulation at Thales Avionics. I am member of the former EASA SSCC, Safety Consultative Committee. I am a member and former chairman of the EUROCAE Technical Advisory Committee. And previously, I was head of Thales Avionics Design Authorities for Commercial Avionics. and also technical advisor to Cesar and EGEN. I am involved in many avionics design and innovation, and I am holding many patents.
So, Marc Parisis, working in Airbus. I am an airline pilot with a training background. I'm also a test pilot. And in Airbus, I'm dealing with all flight operation support, services, and training.
Thank you. As we speak about A, let's speak about B.
All right, pilot from B, Philip Adrian, Boeing Chief Pilot, Regulatory Strategy. My career started being a pilot in the Air Force. After that, I've went through commercial aviation. I'm a current captain on 737, 777, 787, and I instruct on all of those as well. Besides that, I'm responsible for the operational suitability data for Boeing and the entry into service of new airplanes, 777X, 737 MAX, and what comes beyond that. Lately, I've also been involved in the efforts regarding upset prevention and recovery training, where I chaired the ICAO panel of LOCART.
So, good afternoon, everybody. My name is Willi Wesendorfer. I represent European Cockpit Association, and my career started as a flight instructor at Aeronautics in Austria. Then I was employed as a flight instructor at a Lufthansa flight training subsidiary, Intercockpit Pilot Training Network, as flight instructor, team leader, and finally deputy chief flight instructor. Thereafter, I followed a call to develop a new ATO for a business jet operator to supply new pilots for their business jet fleet in Austria, Jet Alliance. And since 2007, I'm employed first at Tyrolean Airways, which is now Austrian Airlines, flying Canada Regional Jet and now Fokker 100. And to EASA, my relation is representing European Cockpit Association at the TAG SEC meeting, Aircrew Training Policy Group, at rulemaking tasks for the learning objectives and the instructor and examiner rulemaking task. And yeah, that's it for the time.
Thank you, Willi. As the subject is rather complex, we thought the panel it would be a good idea. We start by setting up the scene. Where are we today? Based on facts and data without any interpretation. So this is a well-known chart, which is describing the accident rate per million hours, rate evolution versus time, and across different generations of aircraft. Perhaps Mark, who gave me this chart by courtesy, could describe better than me what is a second generation, third generation, fourth generation aircraft in a nutshell.
Yes, so clearly this deals with the level of technology that you will find in the various aircraft. The question that we have on that chart, I think, obviously the latest generation, including the fly-by-wire aircraft, is that we see that the accident rate is obviously lower, however, it's at a plateau. That's why we have this question mark on the fifth generation coming from EASA.
So if we take the curve describing the evolution accident rate versus time for the fourth generation, as Mark said, we are reaching a low number and also a kind of asymptote. So most probably the audience may be curious and would raise the question, what should be or could be the fifth generation? The one ahead, which is not described into that chart. Here, I wish to make an analogy about what we have seen in the engine developments. For a long time, there were continuous improvements on the engines. The engines were continuously improved, step by steps. And all of a sudden, there was a technological breakthrough, and we have now the LEAP engines. This is raising the question for the future on what could be those technological evolutions, but versus what could be as well the humans which will be in the cockpits at the same time. So perhaps there is a double evolution to be considered by the panel. We are not very sure that future pilots, which will fly the 5th generation, will have exactly the same social aspirations, will have the same behavior in front of automatisms. They are, so to speak, born with automatism. So these are the kind of questions which the panel is taking into consideration when we will develop a discussion about 5th generation. What could it be? I made this slide internally with our data, safety data, because I was quite interested about what was evolution and what is experience we have gathered so far in Autolands. This chart describes the number of events, so they are not fatal accidents, there are events. And you can see that if you read the chart from left to right, for instance, there are some blocks which are blank. That means we had no events. If I would raise the question, when do you think that, at what time landed the first plane with passengers on automated mode? Pekka, you are an old guy. You must know the answer. 65. The first landing occurred at Heathrow, the British Airways back 11, with two autopilots working together. And for the internet audience, in foggy conditions, what we call in under specialist category 2. So I've been advised by my people not to take any conclusions from the numbers because they are too low statistically, which is true. But the trend is interesting. And I think there is a lesson to be learned. I may raise the question to our panelists, why don't we have any automated takeoff? The people listening to us probably have some people experience, and they know by experience it's much more easy to land the plane than taking off. And here, curiously, in the automated system, we have an apparent paradox. Automation is bringing challenges. Those challenges are closely monitored by the agency. And here I wanted just to make you aware about a couple of SIBs. So I briefed my guys not to use acronyms unknown, so a SIB is a safety information bulletin. It's a bulletin that the agency wishes to issue as part of a safety promotion pillar, and this is very important. I take just two as an example. I will not elaborate on it. Use of erroneous parameter at takeoff. It is clear if you put into the computer, like at home, the wrong data, the computer will not behave in an optimum manner. Same for the aeroplane mode awareness during final approach. If you put your automated system, let's say, in an operational window for which it was not really conceived, the automated system may react in a curious way, just because he is taken out of his, so to speak, operational envelope, system envelope. Just food for thought, and that will be the last one. I don't want to take too much time. We were all trained with a training paradigm, and this one remains. first fly, after navigate, communicate. Let us speak about the time a pilot uses to manipulate physically the controls. Under the control of my friend Philippe, we took the example of a Dubai theater where there is an augmented crew, 4 pilots, according to the FAA rules, I guess, and 1 pilot only may actually fly the plane for something like for 1 minute, assuming he uses autoland at the destination airport. If he does not do that, probably the flight time, I mean physically at controls, flying manually the plane, will be a couple of minutes, not more. And this is probably a question we wish to debate into the panel as well. So, I think it is time we go now in the first presentation. So, Hugo, would you like to guide us in your presentation?
So good morning. I will provide you a vision of what we see as an industrial for avionics for the coming years, the future. So behind the question of less human involvement, which is the purpose of this presentation, comes the question of autonomous aircraft. But is fully automated air transport a dream, or will it be a reality? Will an automated system be able to perform a complete flight? A reasonable answer is today most probably yes. Typically, current generation UAVs and even piloted aircraft are actually not far from this objective. But though full automation is foreseeable, what about safety? Will this bring more safety? So behind this question of fully automatic flight, however, there is also the question of the ability of the programming system to deal with all type of situation. And though performing a normal flight fully automatically is close to be feasible, dealing with all types of situation is a more tricky issue. The recent crash caused by a first automatic driving cars illustrate first, the technical difficulties to provide the system with the ability to think and make decisions at least as a human, or preferably better. And the issue of liability, since liability for operation is now transferred to the designers. So, the environment will always be by nature non-deterministic, and we have to work with that. For this reason, humans will need to be present on board the aircraft at least still for a long time to come. At the same time, systems are becoming even more complex. This in turn requires greater automation in order to maintain pilot workload and awareness at an acceptable level. Therefore, increased automation should allow for an effective cohabitation with humans in order to maintain or preferably increase safety. Next. So our vision of the 2050 avionics involves significant evolution in human-machine interaction and supporting avionics architecture. In the following, this presentation provides examples of avionics system evolution and innovations that are currently under study. Their drivers are more automated systems, simpler to operate with more robust safeguards. Among those evolutions, following examples will be addressed during this presentation. First, Avionics 2020, next cockpit generation, including integrated HSI, a new head-worn display, and a new concept called fly-by trajectory. So, we are currently involved in preparing the development of a next cockpit generation in which many new innovations will be integrated in order to provide pilots with more efficient and user-friendly systems. Every step where more automation is relaxing pilot workload is forcing as a step to improve not only efficiency but also safety. This new cockpit generation is oriented towards cooperation and mission in a connected environment that is increasing every day for better pilot understanding and decision making. It is organized around several large displays and enables the use of touchscreen technology to implement smartphone operation concept. As important is also the information displayed, which provide better situational awareness with regard to its flight path and the external environment. So as an example, integrated HSI of today, organized by function, will be replaced by a large interactive display, which will be organized by interactive object on which the pilot may get information or activate commands associated to this object. Next. Yes. As another example of the avionics 2020 is the way the flight log is foreseen to be displayed by new formats, providing more information. Typically, depending on crew interactive selection, could be presented a mission view or a summary leg view, or going down into the details of the flight legs. We are also currently developing a new system to allow pilots to safely fly and efficiently manage a mission. This is a head-worn display, which will provide the pilots with a symbology like the one on a head-up display, with 360 situational awareness and synthetic vision symbology. Differently from head-up display, displayed symbology may be presented even when the pilot is looking on the side. This is typically a system where significant safety improvements are expected. That's not new technology. Yes. So, in addition to previous new systems, new innovative flying concepts are also under development, such as a flyby trajectory. Purpose is to provide pilots with the ability to fly accordingly to the aircraft future trajectory and not only with the current aircraft status. This concept is developed in successive steps, the first one being the permanent display of the computed trajectory. Further steps will be to adapt the future trajectory according to new protection function until a full deployment of the flyby trajectory concept. So in the short term, flyby trajectory is designed to provide an easier and more efficient flight management based on a permanent display of the computed trajectory. So let us look at a short video on that.
Today's piloting requires gathering lots of data from different systems through several cockpit interfaces. Understanding the system state is a major part of pilot workload and training, thus leaving less time for trajectory control and surveillance. Therefore, Thales engineers, working with pilots, developed a new solution called flyby trajectory. Didier Poisson, Thales test pilot, will show you how the system works.
I'm approaching Nice Airport, and flyby trajectory is showing me my trajectory that I have to monitor and that I can control at any time. Everything is grouped on the primary flight display with a performance scale, a velocity vector, flight path angle, and different targets that the pilot can easily set. On current aircraft, all informations are coming from different systems, and the pilot has to monitor those systems, which is a high workload. But the main task of the pilot is to monitor the trajectory. It is why we have developed flyby trajectory, is to help the pilot to concentrate on its main task. For this approach, because of the wind condition, I will have to go downwind to do a U-turn at the end of the downwind. Flyby trajectory is showing me and helping me to select a new target. It will be very easy to stop the aircraft at a given altitude, which is shown here, 1,500, and it will be very easy for the pilot to send the aircraft to the desired track, which is 070. The new target information is now shown on the display, and the pilot has to turn on the track that he has selected. We are at the end of the downwind, and I have to turn back to the runway. This task is not an easy task for an airline pilot, because you have to follow a very precise track and to be stable and final. Flyby trajectory is a system which will help the pilot to monitor his trajectory on curve approach, to have a constant back angle, and to monitor that his trajectory is going toward the runway. It's a very natural flying thanks to the trajectory which is permanently shown. My trajectory is therefore shorter and more stable. This will dramatically improve the aircraft stabilization, and therefore the occurrences of go-around will be less frequent, but in addition the trajectory is permanently protected in case of a threat, which is traffic or weather or terrain. The threat will be displayed to the pilot. If the pilot fails to react and correct, at the end the system will take over and put the aircraft in a good and safe condition. Flying by trajectory is giving several benefits. First, it's intuitive, easy to use, and it reduces, therefore, crew workload and training. Trajectory is shorter and more stable, reducing fuel and flight time, which is better for airline and for the environment. The system is constantly protecting the trajectory. As a pilot, I definitely believe that flyby trajectory is improving trajectory control, flight efficiency, and flight safety.
So thank you for this one. And in the medium long term, yes, it's the flyby trajectory is designed to provide for a permanent flight path management for a connected and continuously protected flight. Let us look at another but very short video now. So, just a part of the last slide. Several lines. So up to now I present you new system and concept review of 2050 avionics. But coming back to the purpose of this conference, raising the question, are those increases in automation are more safe or not? First, it should be recognized that the initial goals of all those innovations is to increase safety while simplifying crew operation. But this objective is not sufficient by itself. Safety is not granted only by additional automation. a lot of associated and parallel activities need to be conducted to ensure a safe introduction of those innovations. Based on our accumulated experience, those associated and parallel activities to consider are an upstream dialogue between industry and authorities should be ensured. Industry must familiarize authorities on new technologies or innovation with, as far as possible, demonstration means. More essential is to ensure confidence between authorities, industry in building towards safety. Strong coordination is needed in order to cover at the same time the various safety-related aspects of an innovation, certification, but also flight standards, training, and manufacturing. A very valuable step towards safety is authorities challenging and helping the manufacturer towards safety together with the availability of appropriate and engaged experts. On this side, industry must be proactive, typically in promoting standardization and rule-making proposals. But in any case, a progressive and consistent certification approach based on experience should be ensured in order not to kill innovation while increasing safety. And just to summarize, improving pilot efficiency while enhancing safety must be based on innovative systems which design first put humans at the center of the decision process, don't use human resources for tasks a machine can do, limit the impact of inevitable human shortcomings, and develop in full collaboration between industry and authorities. Thank you very much.
Thank you very much, Hugues. Could you go back one slide before?
I will try.
The previous one. Voilà. Looking to our manufacturers, Boeing and Airbus, do you share this rulemaking certification approach? We have a famous dichotomy between one side the need for the passenger to ensure the achievable safety, but also to make best use of a new technology, which also is a benefit for the European citizens by fostering employment, for instance. May I have your feelings?
Looking at this, I believe I probably speak for all major manufacturers that we're looking to improve the technology, the simplicity of the technology and the human-machine interface, while looking at increasing safety through doing that. This is not a safety-only driven, it's also efficiency driven, it's looking at the entire infrastructure, but in the end safety must be at least at the same level and hopefully increased through the use of this, and the way to do that is to have all parties involved, that is the manufacturers of the technology, the manufacturers of the airplanes, the regulators, and all the other invested parties.
Thank you, Philippe. Mark, no? No comment?
No, as Philippe said, this is obviously shared by both manufacturers.
Really, something to add quickly?
Yes, of course. For us pilots, it's important to stick to basic flying manual handling and to keep these basic principles as a deep foundation of what airmanship means. New technologies may support and assist and give additional information, increase efficiency, but the first goal must be increase safety. What we learned from experience with the new generation of students is that they have a reduced understanding of what airmanship is, because they see all this flying an airplane as like similar to a computer game. And we should have a focus on not training them to play a flight simulator or similar an airplane. They need to understand what they are doing and understand what aerodynamic can do and what basic airmanship is, and don't trust and too much into all this technology That's our message here.
Thank you, Willy. Now I wish to turn to Marc, who may provide his feelings about the question we are debating within this panel.
Yes, so obviously, as said before, clearly the increase in automation is there for increase of safety and efficiency. That's quite obvious, and we can see it. And George, you talk about the Autoland. I can also talk about the something that you have in your car, but we also have on the aircraft, is the anti-locking braking system that can do better than any expert can do. So obviously improve in efficiency, improve in safety, thanks to the automation. However, still room for improvement. Clearly, we always need to enhance continuous development, the interfaces, the new function that we can have. And the objective is to make it simple for the pilots to give synthesis. I can take one example on the Airbus fleet with the Qantas 32 incident taking off from Singapore with this engine failure and following a lot of malfunction. So can we improve the system that can provide synthesis to the flight crew? Yes, and we are working on it. So always room for improvement. The idea is to support the pilots in high stress situation, peak workload situation by simplification, by providing synthesis for the pilots. So increase in automation, obviously increase in safety and efficiency. However, I think there is a simple but very important drawback that has just been said to the automation. So simple but important drawback is that you don't know how to do it without the automation. You don't know how to do it without the automation. So what does it mean? In some cases, for example, the Autoland, if the automation is not available, I would say in terms of safety, it's not an issue. You are just not authorized to do the Autoland. Okay. But we have a lot of non-normal situations in case of failure when the answer, as per design, is to the pilot will take over. So how now you give the responsibility to the pilot to manage a situation that he has been using the automation, and how can we make sure that the pilot still know how to do it without the automation? So this is our challenge we need to tackle. So obviously how we can do that is through practice. You need to practice. And I would say there is two paths to practice, two paths that are parallel. One way is to practice in line operation. So it means that you will not use all the level of automation available. So be careful of that. You really need to conduct a safety risk assessment. You have to really think about it. That means that you will have flying with passenger in given situation without using all the automation available. So here you need to have a clear airline policy following this risk assessment. And then I guess that this risk assessment will tell you not to do it in case of fatigue of the pilot, in case of bad weather. So the opportunity to practice could be very low. The second path that I want to highlight now is to use the training device on ground. So either the 2-day training device, and we have some wonderful training device, the full flight simulator being one of them, but also to develop new training device adapted to this new context. So I really think that it's our responsibility all together. So it means in the aviation industry, the operators, obviously, the regulatory agency and the manufacturer, but also the training device manufacturer to think about that. If I may remind you, 30 years ago, we had a big change in the training industry that was following this accident. Can refer to the Tenerife 747 accident, can refer to the DC-8, United DC-8 at Portland. All these accidents make a big shuffle in the training industry by the introduction of human factor, CRM, crew resource management, loft, line-oriented flight training, where we really 30 years ago changed the way we were training the pilots. I really think that today it's time to have a new training model. Today we have a new context, it has been said, also maybe new pilots joining our industry, but a lot of automation. We know that RVSM, so I mean reduce vertical separation minimum, does not allow anymore the pilots to fly manually above flight level 280, so it means during cruise. We know that we have more and more RNP approach, so let's say GPS guided approach where you are not authorized to fly manually. So we have more and more automation in operation, so it's our responsibility today to change the training scheme, to change the training model by introducing new training device, a better use of full flight simulator, and I think it's time to do it. Merci.
Thank you very much, Mark. Probably the audience or the one who know a bit of Airbus design would be curious to know what was the driver, the rationale, so as the TCAS maneuver is achieved actually by the automated system. What was the driver and the why is perhaps part of my question, and more generally the process. How did you go there?
Okay, so George is referring to the TCAS, so the Traffic Collision Avoidance System, very great tool, really increased safety. That will provide the pilots with an order in case of conflicting traffic to descend or climb or maintain vertical speed, so a vertical avoidance of that. Actually, we think that looking at some in-service event where the pilot reaction was a little bit too much, so the vertical speed that was targeted was really overshooted, and the idea that was in this situation of high stress, high workload because of this alarm coming on, and the need to avoid the traffic, this is where we want the automation to support the pilot. So we said that the automation, so the autopilot, but first the flight directors, because you can also do it flying manually, but the automation will support the pilot in doing the exact needed trajectory and not more than what is needed. So this is for us the objective of the automation.
So in short, if I'm not wrong, listening to you, there was a balance achieved between the human risk and the automation system risk.
Yes, clearly, once again, the autopilot TCAS that we have on Airbus fleet is not a mandatory device, so you can fly without it. It's just there to support the pilot, and we really think that this is our objective using the automation, provide the pilots, specifically in this high workload situation, with the good support. But the pilots are still to be able to do it without this system. And that's what we do in the training with the autopilot TCAS and without the autopilot TCAS.
Thank you, Mark. Now it's my pleasure to invite Philippe to take the floor.
Ladies and gentlemen, good afternoon. First of all, thank you to EASA, Director Key, and the Slovakia government to have us here. Really appreciate the possibility to speak here and to have these discussions with you. And this should be a discussion more than anything else. Because of that, I'll keep my presentation really short. Just like Mark, I think as the OEMs, we have a very similar view of safety and safety improvement. What we've seen lately is highly publicized events with autonomous vehicles. Tesla comes to mind, Google self-driving cars. We even saw DARPA, the Defense Research Institute in the US, publicizing a so-called unmanned airplane with a pilot to be a safety event. And even this morning on my flight over, I saw an article in USA Today that said, if Batman would have a tractor, this would what it would look like. And it basically is a farm tractor that doesn't need a farmer to drive it. So it's going everywhere. Aviation is only one part of the transportation. However, what is not always clear in these kind of events is how these vehicles fit into the entire infrastructure rather than being a science project, and at that, very interesting. As stated before, and I think we all agree, and the first slide that George showed, automation has increased safety. In the end, however, our goal as OEMs and of the entire aviation infrastructure is to go to zero incidents, accidents. And that is not something that we can trust automation by itself. It will require a clear and simple interaction, like Hugues identified, between the pilots and the event that is supported by the automation. The pilots are part of this decision-making process. They're the ones that carry the situational awareness, and as Mark identified, supported by the automation. We have to look at how airplanes are designed. Airplanes are designed according to statistical, and we're talking about extremely improbable, 10 to the minus 9th. It's a chance of 1 in a billion. If you would play the lottery, you wouldn't play it. On the other hand, a date with Cindy Crawford, every man would say, well, there's a chance. What we have to look at, though, is extremely improbable doesn't make it impossible. And not all the events that are extremely improbable can be fit by design criteria. Some things cannot be designed out to 10 to the minus 9th. In the OEM world, we have to identify a crew safety procedure to maintain that extremely improbable statistic through a crew interaction. So we have to make sure that there is clear interaction between the crew and the automation. We do that through all kind of testing. We use what is called average pilots. Now, there's no such thing as an average pilot. Every pilot is better than average, myself included, of course. But in the end, we are required by law to use an average pilot. That's a pilot of not the quality of Mark, not a 20,000-hour airline captain, but also not somebody that's an extreme novice. Regulators form this role. EASA and FAA assist all our manufacturers, Airbus, Embraer, all of us, with this system. And we try to make sure that the systems are interactive with an average pilot, whatever that is. So, besides that crew procedure, we also need to understand that automation can only do what it's designed for. However, operational decisions, a diversion because of a passenger getting sick, weather situations, an exceeding crosswind that is different in the air than on the ground, which happens all the time for us pilots, all these kind of things need human interaction. So we need to make sure, and I fully support what Mark said, we need to make sure that we have a fully trained, qualified pilot in the flight deck. Just to support that, in the Boeing manuals, we always expect the pilot to be fully trained, qualified, and current on the airplane. That is our assumption for the safe operation of the airplane. And I believe that's in the same kind of realm that Airbus has. So what we have to understand is that design can only deal with a known threat. And I will support this with a video in a second. We also know that when that known threat is identified, we make sure that the design functions against that threat. But without focusing on the larger picture, pilots and everybody alike might become automation dependent or automation reliant. So we need the automation to support or even to do the actions. And we need to make sure in aviation, especially through training, that we reduce that reliance on automation and that we make pilots the pilot and the final decision maker in the airplane. Before showing the video, I want to make sure in conclusion that a machine has no judgment. Judgment is used by pilots or by people only. This machine follows strict design criteria, and it does what it's intended to do, and it quite often does that really well. However, when a situation, or for whatever reason, it's asked to go beyond this design criteria, we don't know what it's going to do because it's not programmed to do so. And even though it's exactly performing the job that we want it to perform, it might not be an improvement in safety. So we always need, and will always need, until Hugues comes up with something that replaces the judgment of a pilot rather than the skills, we will need piloting skills to be maintained and to support operational safety. To show this, I want to show a video that is not aviation related, but I think you will see why I'm showing this.
Dieser zur Unfallverhütung konzipierte Nachrüstsatz für Motorräder wurde von TFK Engineering entwickelt. Die technischen Details sind vertraulich, aber wir zeigen Ihnen die wichtigsten Eigenschaften des Prototyps. Der integrierte Computer überwacht die Radumgebung mit Hilfe von Video- und Datenübertragung. Das Programm sucht fortlaufend nach Risikofaktoren wie zum Beispiel Fahrzeuge und Fußgänger und analysiert Tausende von potenziellen Gefahrensituationen. Es prüft an einer Kreuzung zum Beispiel, ob ein Autofahrer sie gesehen hat. Die ermittelten Risiken werden an einen außen am Fahrradhelm angebrachten Empfänger übertragen. Und der Fahrer sieht auf einem im Helm integrierten Display, wo und worin die Gefahr besteht. Das Auto fährt auf die Kreuzung zu, ohne dass der Fahrer prüft, ob sich ein Motorradfahrer nähert. Das Fahrrad erkennt dies als potenzielle Gefahr und warnt seinen Fahrer rechtzeitig. Wir können die Aufnahmen aus dem Helmsystem herunterladen und Ihnen genau zeigen, was der Fahrer gesehen hat. Dann mal los, Karl!
Komm es an! Oh nein! Es hat Karl erwischt! Schnell! Jetzt komm doch her!
So, to help recover the shock, I would have a question for Philippe. Which is, in fact, I wish to share with you a EASA experience. It happened to me, I was speaking with one of our a light aircraft certification flight test pilot, and he shared an experience with me. On a light sport aircraft, I do not wish to name the name, there is a blue button. And if you push this blue button, the plane automatically recovers. And he was a bit more descriptive. He told me what he did as a maneuver. So I would use my hands, 120, 40 degrees, like this. You push a button, the planes recover. Conversely, an attitude like this, you push the button and the plane recovers. And it was successful. So my question is relatively simple. Do you see any future for such a blue button? One day, I could raise a question to Mark as well, by the way, in the world of commercial transport.
Yes, so actually we are working on this kind of support to the pilot that will help him in case of upset situation to what to do. So it's not the automation that will do it, but the automation will provide the information to the pilot. So enhance information in your instrument, in your display, where you have to use your bank to turn the bank to the pitch, so very similar to what you say, but actually want to provide information to the pilot, so a better situation awareness for the pilot, how to recover. That's one of the answers. Then, without reaching this kind of upset situation in which we want to provide information to the pilot, we also increase the robustness of our autopilot system. So it means that even in case of hydraulic failures on the A350, you will still have the autopilot available. And we also think about a very basic, simple mode of autopilot that could be able to work even with less information than the one required today. So basic autopilot required to go to a pitch and choice for the auto choice, so more simple way. So in a way, that's the answer we provide, always putting the pilot in the center, so we try to enhance the information to the pilots, but the pilots will still be at the center of in our cockpit.
Thank you, Mark. I guess once again we're completely aligned. However, to add to that, I've had the privilege, as I indicated before, to chair the ICAO LOCART and also the EASA Upset Prevention and Recovery Training Rulemaking Task. One thing that we go past in these kind of events is that we expect pilots to be engaged and trained. In these situations, there is a large discrepancy between where you were and where you should be. And we would expect pilots to be engaged in their flight. And as soon as their flight path diverges from what they're intending to do, to take action right away, to not end up in these kind of situations. In the end, a well-trained pilot should be able to recover from this with the help of the instrumentation, as Mark identified. But also a well-trained pilot should be able to avoid, in most or hopefully all possible cases, this situation through the use of his skills and his situation or her situational awareness.
That's a very nice example you presented with a blue button which is able to recover an unusual attitude on a general aviation airplane. But you cannot really compare that with an airliner, because the general aviation, single-engine piston aircraft maybe, does not have the computers on board like an airliner, with envelope protection and stall protection and whatever protection there is with hundreds of computers in an airliner. So if an airliner comes into an unusual attitude situation, already the automatic had some errors, and I think the backup of a failed automatic system cannot be an additional computer which may recover then an unusual attitude. So that might be good for general aviation, and let me call it I'm afraid button. If you don't know what to do, you push the blue button to recover. But I think for the airliner environment we should go a different approach. I could envision that then if the bank is exceeded the limit or pitch is exceeding some limit, there is a feel feedback on vibrate, maybe like a stick shaker or just a feedback, but the last line of defense must be the pilot.
Thank you very much, Willy. You just remind me of French say, the best is the enemy of the good. So let's go now in your presentation. May I ask you to be relatively short because I wish to have to answer some questions.
Of course. Give me 4 minutes.
Chrono started.
So, good afternoon, ladies and gentlemen. Thank you for the possibility to speak here today on behalf of the European Pilots Association. My question today is if you would take that flight with this pilot. Today we are talking about automatism and maybe robots in the cockpit and what computers can do. And first of all, I have to say we had now the last 2 years, the safest 2 years in aviation since commercial human flight in the last century. And the question is this because of well-trained pilots or despite pilots are doing their job in the cockpit? That's the question of today. So the next question is, are we flying these high safety standards because of technical evolution or because of improved training standards? I think it's both. It's training and it's improved training standards, of course. Aviation is one of the fastest growing businesses of the world. And yes, human factors are still a contributing factor to incidents and accidents, but there is no statistic about the thousands of incidents and accidents which did not occur because pilots are doing their job every day, every minute, even without any public attention. So, it's very desirable to transfer routine tasks to automatic system, but automation brought additional safety factors. Automation brought additional safety factors, of course, but the human factor must be in the center of automated system design. And if we try to get rid of the humans in the cockpit by design, we simply transfer the human error into the design phase. This would make the human design error more anonymous. Who will then be responsible for things going wrong? So we know all the story of the autopilot and what autopilot can do. But important is, as long as we need pilots, they must be included in all thoughts about future cockpits. The design of automated systems need to be transparent and easy to use. Ideally, it would also contain the aspect of intuitive handling. So, modern avionics can fly and control an aircraft almost 100% automated, while pilots might find themselves in an abnormal situation with a complex environment from 1 second to another, if automation fails. This fact, from my point of view, makes it vitally important that pilots use all opportunities to train and maintain their manual flying skills. From some companies we know that they tell their pilots to use automation, autopilot and autothrottle as much as possible. That means pilots are not flying manually anymore. So training the manual skills is consequently reduced to 2 missions in the simulator per year. That is not enough. And Mark, I want to answer to your presentation before 2 points. First, you mentioned the use of simulator. There are new systems, we call it system trainer, which should be really used more increasingly. Because for us pilots, it really does not make sense to use a very high sophisticated, high fidelity full flight simulator level D to read checklists. A full flight simulator should be used for what it's designed, for training manual flying skills. And to train system understanding, I think a full flight level D simulator is maybe too much. It could be covered, such trainings could be more efficiently covered by system trainers. Let us use level D simulators for what they made for flying and training and manual handling of an airplane. And the other thing I would like to mention to your presentation before, you brought the example of 4 pilots flying 1 minute on a long-haul flight. So in my company, we have a policy that we may fly manually with, of course, a risk analysis, not if the traffic situation is too dense, if the weather situation is challenging. We should not fly manually maybe at 3 o'clock in the morning when the Cardanian low is really there. So there are some lines of defense we should give respect to. But we are allowed to fly manually after takeoff as long as we like. By regulation, we have to switch on the autopilot below flight level 290. So that's not what we do. Yeah? But it makes sense if the weather permits, the traffic situation permits, to fly manually at least up to flight level 100 and then engage the autopilot. That's good for manual practicing, manual flying, and I think that's not unsafe. And the same during descent if the traffic situation permits. We should be in training, and it's our daily job to fly airplanes. So I think company policy should permit that with a proper risk analysis, of course. The reason for 2 qualified pilots in the cockpit is still the management function. Managing the whole environment on ground and in the air, pre-flight, in-flight, post-flight, and finally building the last line of defense if automation fails to recover. This is the duty of pilots. Finally, coordinating the whole orchestra in and around the relevant flight. This cannot be transferred to any robot. If computer programs were based on all the experience and data which we drew from all past flights, including all incidents and accidents in the computer software, the software still would probably still be limited to apply routine tasks from this limited resource. Imagine the Hudson River landing. No computer could have been creative enough to assure such a life-saving outcome of this event. Every flight is different, every flight is new, and every flight requires thousands of decisions made accurately in time to respond to the living and fast-changing environment of weather, air traffic, separation, passenger safety, economy, and comfort. Of course, drones can fly independently. Cars drive remote controlled or even automatic, but still, the safety statistic of modern aviation would result in dramatic rise of incident and accident rate if no pilot were there anymore. So, what we envision as European Cockpit Association, pilots must be carefully selected and monitored by training facilities and safety management systems. And the European Cockpit Association also promotes an ATO, and flight school independent pilot selection, ab initio, and proper training in both automation and manual flying skills. Thank you.
Thank you, Willy. I think I have one short question from Mark and potentially a comment from Hugo linked to your presentation.
Yes, so I think we totally agree. Better use of full flight simulator. And that's something we really need to develop because, as you said, this full flight simulator is a wonderful tool that's very high fidelity on the aircraft compartment in terms of manual flying, and we should not spend hours in the simulator with the autopilot, obviously. Better use of simulator. One comment, I said we really need to train to fly without the automation, and automation is not only autopilot. This includes the flight directors. So when we see pilots saying that they are flying a lot manually, actually, if they are just following the flight director orders, for me, they are not really flying, because to fly manually implies to have the brain in activity and not just the hand following the flight director. So then when you do this risk assessment about in which condition I will set up my airline policy to allow manual flying, take that in consideration. Obviously, the way the aircraft is designed, you may be in a situation that you will have no more flight directors, you will have no more auto throttle or auto thrust, and you must be able to fly. If you have been practicing following the flight director using the auto thrust, in terms of safety risk assessment, it could be a green light, but actually you are not practicing the full raw data manual flying. That's why I think we also have to change, once again, together we need to change the training scheme and introduce this new way, due to the new context we are in the flying, in the aviation industry, and to do this pure manual and flying with new training device, or use also new training device to free some simulator hours to use the 2-day simulator slot. That's what the comment, but I think we agree on that.
Thank you. Okay, thank you. A small comment on your side, Hugo.
Yes, I may have a comment from an industrial viewpoint. The most exciting thing of our design work is not to develop a system that works. This is too much simple. But a system that will continue to operate almost properly. It means being resilient to any foreseeable failure, intrinsic to the system or failures within its environment. So safe flight is ensured by both such resilient system and by trained pilots also.
So thank you for this inspiring vision. I wish to open the floor now for any questions, comments, please. So, if I have no comments from the floor, no hands raised, okay. We'll take one coming from our Webbers looking at us. More automation, less human involvement. Who will be responsible in an accident if an incident happens? The software developers, the pilots, ATC, etc. Who may provide this answer?
Well, I think, speaking from a manufacturer's perspective, we shouldn't be looking at responsibility and blame. This is not the way aviation safety improves. We should be looking at a zero accident possibility and how do we get there. So rather than looking at the result and trying to identify and point fingers in who was to blame, let's learn from this. That's the way we've done it in aviation over the years. Let's learn from our past events, make sure that we're not focusing on fixing a past event, but that we're looking broader than that we're looking at the skills, both the airplane skills and the piloting skills, to provide the passengers the safest experience possible. So in conclusion, I really don't care who the responsible party will be, as long as we can increase safety by being ahead of the accidents. That is what we should be aiming for.
An essential element of the safety improvement are instructors, qualified and good trained instructors, and of course examiners. So these should be the core of pilots who really know how to not only do it right, they should also know to transfer knowledge to the normal pilot who is not instructor, examiner. And we really need to focus, and that was what EASA right now does with the rulemaking task for instructors and examiners. We need really to be careful changing some elements in these instructor and examiner requirements because we are already safe, and we should be aware of not using arguments from economic pressure to change the regulation accordingly. We have really to consider on the first glance safety is the most important fact, and then comes economy.
Thank you. We have one question from the floor. Most welcome. Let's go ahead. That gentleman needs a microphone, I guess, huh? Okay.
So, I'm here to help you.
Hello, my name is Captain Fatih Temel from Pegasus Airlines. We are based in Istanbul, Turkey. I'm a former Air Force pilot as well, F-4 Phantom. I was interceptor. And since 2011, I was flying as a pilot for Pegasus Airlines. I started flying with Boeing. Now I'm flying for 2.5 months. I started flying with Airbus 320. We changed aircraft type. I want to comment all of you to support your feelings. Flying is an addiction. Flying is the freedom. And as pilots, we have to have certain skills. If the scientists wouldn't have find a new way of flying, I know from Discovery they're trying to find some machines not flying, just floating in the sky. If we still continue to fly the aircrafts with the same philosophy, yes, we have to encourage our pilots to maintain their basic skills and let them or give opportunities to advance their skills for decision making, for the aspect of safety, and we have to provide training and try to find the ways to make them less errors, and but we have to maintain the basics. When I was intercept pilot, I was having seizures in the sky with 0 speed. But when I became an airline pilot, I was more addicted on the flight rules. I'm never trying to fly in an aircraft with a speed of 0. But according to the situations, we have to adapt ourselves. You know, the technology is growing. As the technology grows, we have to find ways to adapt ourselves to new developments. Thank you.
Thank you so much for your comment. I think I want to reiterate, Mark and I had the pleasure to present last year in Luxembourg. And one of the things I think we all agree on is that 5% of the flight time takes place in the area where we do about 95% of our training time. That's at low altitude, where the air is dense, where we know what's going to happen. A lot of it is following regulatory compliance. It's engine failures. It's a single engine approach. It's all these kind of things that all pilots know what to expect. Where, especially on long-haul flights, the identification that George had, pilots are a passenger in our own airplane, and they're not aware of the differences in aerodynamic, the differences in airplane behavior at high altitude. So one of the things that we have recommended in the EASA rulemaking task for upset prevention and recovery training, and I believe Airbus and Boeing are both doing this more, is the manual handling skills of pilots, not only at low altitudes but also at high altitudes, because there are significant different in airplane behavior and in the piloting skills that are needed to maintain those kind of skills. We don't want the pilots to only be a troubleshooter in the event that the automation gives up. Willie identified that the automation, if it puts you into a situation that you don't want to be, it might not be the preferred way to get out of it. The pilot needs to understand the handling capabilities of the airplane, and therefore he or she needs to be trained accurately to know what to expect when the airplane or the autopilot gives up.
Thank you very much for this question and this detailed answer. Yes, we have a second question.
Hi, Norwegian, and we're talking about automation, and we're talking about training for different events. I also have a background from the Air Force, so I've been upside down a few times and know what it looks like. But what we're seeing in many cases these days is that the high-risk events that we encounter in the airline industry are kind of black swan events. We haven't seen them before. There are no checklists. There are no training that can accurately predict those events in the simulator, so you can't train for them. And my question is kind of, how do we actually prepare a pilot for handling events? It's no checklist, it's no prescribed training. But anyway, we have to do it because that's what we see is kind of developing in the industry.
That's an excellent question. What we're looking at in aviation is the start of evidence-based training. And rather than fixing a past event, we're now looking at the broader skills that an airplane pilot will need to solve future events. So we're not trying to identify, well, an engine failure works like this. We're trying to go above that. And in aviation training, what we're trying is to give the pilots back possibly, but at least provide him or her with the overarching skills that are needed to maintain a safe environment, regardless of what failure will come his or her way. And it might be environmental, it might be an airplane specific failure, but rather than looking at solving specific failures, we're going one step further back and saying, what are the essential skills, and we're talking about knowledge, skills, and ability that a pilot needs to have to safely operate an airplane, whether it's in a just out of the box, taking the ribbon off and you know, flying perfectly well with all automation engaged, or if it's a 35-year-old airplane that has gone through its most of the lifespan and everything in it is inoperable. We need to make sure that the pilot has the overarching skills to deal with all of that, regardless of what comes his or her way.
Let me add, maybe we could
go
imagine a pilot needs a certain toolbox to fly an airplane, like a mechanic needs a toolbox to repair a car. And this pilot toolbox is always the same, whether you fly general aviation or you fly third or fourth or fifth generation of jets. The basic toolbox is always the same, and this needs to be taught in a proper way. And in addition comes a deep understanding of what automation can support you and where may be some failures of automation and to back up that. So it's getting more complex, and the future development of automation should envision the surface between human and computer to make it easy to understand and not more complex, easy to understand and easy and more intuitive to handle these also abnormals and malfunctions.
Thank you. Another question on the back of the floor.
Thank you. My name is Karel Mindl. I'm a former airline pilot. Right now I'm working for Honeywell International in a flight ops department. I would like to return to the beginning of the discussion. The pilot which didn't touch the controls for more than 1 minute during the flight from Dubai to Seattle is not a pilot. Because you must do a lot of interaction with the automatic flight control. You are responsible for the safety. Probably you will enter turbulence several times. You have to interact with the speed. You have to manage the altitude. You have to do a lot of things. And to touch the flight controls 1 minute before landing or for 1 minute before rotation of the plane, this is not a pilot job. It could be done by a monkey. But you are responsible for safe management of the flight. So this is not only about automation, it's about the management, about efficiency, and about safety at the final. Thank you.
Yeah, and one word maybe to add to that is the mentality of the pilots. The involvement of the pilots in their job, the professionalism is something that we need to make sure that is always going to be there.
So we may conclude with a question I was waiting, but which never came. Are the pilots good in monitoring? Who wants to answer that? Nobody?
If nobody answers, it's going to be me again. In essence, humans are not as good in monitoring as we think we are. Involvement into a boring task for multiple hours is not something that we're built for, nor something that we're trained for. We need to make sure that monitoring is not watching something else doing the job that we're supposed to be doing. Monitoring should be active. It should be involvement in decision making. It should incorporate crew management. It should incorporate interaction with the airplane, interaction with the entire infrastructure. If we look at monitoring as watching a computer do its job over the next 14 hours, I'm already getting tired of thinking about that. So let's get away from just thinking that the automation will take care of it, and only when that fails, I will have to take over. Because in the end, I will need to understand all the decisions made, whether they're made by automation or whether they're made by me as a pilot, before I can make the right decision to return to a safe flight path.
Thank you. I think it's time to break up. I wish to thank the audience for its attention and the quality of the questions. Thank you for the internauts who contributed also a lot to the questions. I think that Dominique will answer all those questions by one way or the other. So thank you very much for your contribution and attention.
Thank you very much. I would like to thank all the speakers of today, which set the standard very high for our two-day conference. I would like to remind you of our evening get-together. There will be a couple of buses waiting for us in front of the main door, main entrance of the hotel, leaving at 7:15. So please make sure you're at 7:15 in front of the main entrance of the hotel. Thank you very much. See you then.